Okay, so we'll start now. Last class we discussed about few things, right? We discussed about ARP in different network, how ARP works on different network, and also we discussed what is DNS, and before that we discussed what is default route. Okay, and then we discussed about DNS, and then we discussed DHC. Okay, this is what we covered in the last class. Okay, so now let me open the actual syllabus for this course. Okay, so here we covered till this. So we covered the first page actually. Okay, DHCP we covered till DHCP basics, right? So today we plan to discuss IP classification, binary to decimal, and also subnetting classic. Okay, yes, please. Listen to me. It's not that difficult, right? Many people know if you ask anyone who studied networking or who's studying networking, if you ask them, right, few guys will say the most difficult subject or the most difficult topic is subnetting. Okay, they say which is your favorite topic? I mean, which is not your favorite topic, which is the tough topic in networking? They say subnetting, right? Maybe not few, I can say somewhere around 30%. Okay, and then I just give me a minute. Yeah. The other 70%, if you ask them, right, they would say that which is your favorite topic? They'll say again subnetting. So the topic which happens to be the favorite for 70%, the same topic happens to be the toughest topic for the remaining 30%. So the topic is same, right? I'm just saying, right? This is what I have observed from all my students. That if I ask them which is your favorite topic, many guys will say submitting is their favorite. At the same time, right, if you ask few guys, they'll say which is your toughest topic or the topic that you don't like, they'll say submitting, right? So submitting has got two phases, right? So the easy phase is the toughest phase. Okay, so now let's try to understand what is submitting. So before that, I just wanted to discuss about this case. See, this is going to be a very important session, right? In networking, you go for networking interview or wherever you go, definitely they'll be asking questions on submitting. So we're going to start submitting, but before that, I just want you guys to understand a few things, IP classification. Okay, IP classification. Okay, see, we all know that the IP address ranges from where to where. It ranges from 0.0.0.0. Okay, from there it ranges till 255 dot 255 dot 255 dot 255. Okay, so now how many number of IP addresses we have here, please? It's a huge range, I know, but how many number of IP addresses we have is it's basically how many values we have here? 0 to 250. How many values are there? 256 values. Got it? 0 to 255. Which means here you have 256 values. Here you have 256 values. Here you have 256 values. Again, here also you have 256 values. Which means the total number of IP addresses that we have in this range can be calculated like this: 256 into 256 into 256 into 256, right? Or simply it's 256 power 4. Okay. So which is nothing but if you want to know what is 256 power 4, I'll tell you it is 429 crore addresses. Okay. In terms of billions, it's 4.29 billion IP addresses. So we have these many addresses. Okay. Yes. So now 4.29 billion addresses we have, or 429 crore, or maybe you can call it like 256 power 4, or even some people say it like 2 power 32. Because why? Because IP address is a 32-bit address. Okay. Yes. So now let me write this again. Okay. So the IP address range starts from 0.0.0.0 from there till 255 dot 255 dot 255 dot 255. Okay. Now, this whole range of IP address, right? This whole range has been classified into multiple classes, right? It has been divided into multiple classes, right? First is class A, okay? Class A. Class A. So class A means what is the range of class A? It is from 0 to 127. 127.255 255.255. Okay. See, some people, they'll say that 127 is not in class A. Few trainers, they'll say till 126. Okay, they'll say till 126. See, but actually, the truth is, it is still 127 only, guys. It is 127, but this 127 series is used for a different reason. I'm not confusing you guys. If you go and check with some other YouTube videos or some internet documents, they will say it like it is still 126, but actually it is still 127 only. Okay, so yes, it's still 127, 0 to 127.255.255.255. Next, we have class B. Okay, so class B, okay, let me erase this. Next is class B. Class B, so where class A got over, next we're gonna start with class B. So it is from 128.0.0.0. Okay, and then till 191.255.255.255. Okay, yes, so this is what class B is. Okay, so this is class A, guys. Understand, this is class A, this is class B, and class C. Okay, starts from 192.0.0.0 from there till 223.255.255.255. Okay, next is class B. Okay, so we have 5 classes: class A, B, C, D, and E. Okay, 120, sorry, 224.0.0.0 till 239.255.255.255. Okay, this is class D's range. And then class E, it's the last class. Class E, to 40.0.0.0. From there to 55.255.255.255. Okay. Yes. So these are the 5 different classes we have right now. Can you see? It starts from 0.0.0.0. From there, it's gonna end till 255, 255, 255. And this big range is being classified into 5 different classes. Class A, this range. Class B, this range. Okay. Students, I can see, and I can see your messages in the chat, right? We don't have to argue with this 127 series, right? Let us go with what I've told. Okay. I understand that 127 is for loop back and it cannot be used, but it comes under class A only. Okay. I can see if you guys are answering in the chat. Let's not confuse others. Let's go with this itself. Okay. Yes. So class A, class B, class C, and then class D, and then class C. Okay. So now we have these 5 different classes, and every class has got a subnet mask, right? Every class has got a subnet mask, which means for class A, the default subnet mask, right? I'm writing default subnet mask for class A is 255.0.0.0. Okay, and then this is a 255.0.0.0. That is a default subnet mask for class A, and default subnet mask for class B. So default subnet for class B is 255.255.0.0. And then I hope you guys know what subnet mask is and all, right? We discussed about subnet mask in earlier classes and all. Okay, hope you guys know that. And class C default mask is default subnet mask is 255.255.255.0. This is the default mask for class C. And then class D and E, they don't have actually any mask. Okay, there is no mask for class D and E. Okay, and if you wanted to understand clearly, any network that we use, right? Any network that we're using in the internet, or any IPs that we're using in the internet, right? They are basically comes under class A, B, C only. So these are the classes that we are actually using. And class D is used for multicasting. Okay, there is a concept called multicast in networking. So class D is used for multicasting. And then class E, I really don't know what class E is actually used for. Many people say many things, right? Some people say it is used for future. Okay. Some people say it is used for reserved. It is reserved. Some people say it is used for defense, right? There are many stories that is, revolving around this particular class E. Really, honestly saying, I don't know what class E is used for, right? Many documents, many articles says it is for different reasons. But anyway, one thing that I want to tell you is class E is actually not used right now. Okay, we don't even use class E for any of the thing. Okay. Yeah, some people say it for research purpose also. Okay, but I don't really know where in which research they are using class E and all. Okay. So anyway, so some people say defense, some people say research, some people say reserve, some people say future. Right. Let's ignore class E. Right. Let's concentrate on class A, B, C. Okay. Yes. Now let's try to understand this now. So first, let me open another slide and we'll try to understand what is the purpose of having a subnet mask. Okay. Why subnet mask is required? Please. Yeah, I already told in the classes. So subnet mask is very important. For what it is important? Okay. So see here 192.168.1.2. Okay. This is one PC. And the subnet mask for this PC is 255.255.255.0. Okay, this is a mask for the PC. This is PC1, let's say. And this guy you have PC2. And the IP address of PC2 is 192.168.2.2. Okay. And this guy has got a subnet mask of 255.255.255.0. Okay. Now we all did this in earlier classes. When I try to compare PC1 and PC2, what do you say? You say that they belong to same network or different network. We call them as different network because why? Because we see the network portion of both the devices, and the network portion of both the devices, what? Here the network portion is what? 192.168.1. There, what is the network device? It is 192.168.2. So since the network portion of both the pieces are different, we call them as different network, right? And how do you come to know that this is a network portion, guys? How do you come to know this is a network portion? Because of the subnet mask, correct? Okay, so now you understand that why subnet mask is very important. With the help of subnet mask only, you can compare two IP addresses and you can say whether they are in the same network or different network. If the mask is not given, then how will you know that which is a network portion? Then how can you compare that with other IP address and say whether they are in the same network or different network? Okay, so subnet mask is really important to know whether two PCs belong to same network or different network. Right, that is one important usage of subnet mask. Right, what is the other usage of subnet mask? First, what did I say now? Okay, compare two PCs and say they belong to same or different network. That is possible because only because of the subnet mask. Okay, so what is the other use case of subnet mask? The other use case of subnet mask is, right, let's say I have a network like this 192.168.1.0. Okay, and then the subnet mask is 255.255.255.0. Okay, yes. Now, if this is the network, and how many number of IPs we have in this network is? How many number of IPs we have in this network? Right, it ranges from 1.0 to 1.255, correct? And how many IPs we have in that network? 256 IPs. You got the point. Again, subnet mask is the one which gives the network portion. With that network portion, we can understand the host can range from 0 to 255. So which means host ranges from 0 to 255, which means how many IPs we have in that network? 256 IPs. So basically, I'm trying to say the same thing in two different ways. One is the purpose of subnet mask is to compare two IPs, right? Compare two devices and say they belong to same or different network. Different network. So point number 2 for subnet mask is we can find how many number of IP addresses, how many number of IPs we have in one network. Okay, we have in one network or we have in that network. So both can be identified with a subnet mask only. Without subnet mask, you cannot compare two devices and say what is the. You cannot compare two devices and say whether they belong to same or different network. And also without subnet mask, you cannot say number of IPs we have in that network. Right? Okay. Hope you guys can understand what I'm trying to say. Maybe if you're still confused, nothing problem. Right? I'll clarify. Okay. Now itself. Wait. Now, yes. So now let us take class A, guys. So I'm going to take class A. So what is class A? So we have class A range here. Class A starts from 0 to 120, 7.255, 255, 255. Okay, 0.0.0.0 to 127.255.255.255. Now I'm taking class A, and class A starts from 0.0.0.0. From there till 120, 7.255.255.255. Okay, yes. So now this is what class A is. And now what is the default mask for class A? What did I write here? What is the default mask for class A? 125, which means one octet for network and then three octets for host, correct? One for network and then three for host. Okay, here we're gonna have the subnet mask, which is 255.0.0.0. Okay, now I have a very simple question, guys. Question number one is, I have two questions. The first question is, if this is a range and if this is a mask, right, how many octets on network is? One octet for network, remaining octets for host. Okay, so if there is a change in the network portion, then it becomes different network. Okay, now question number one is, how many networks? I want you guys to answer in the chat. How many networks we have in class A with a given range and with a given mask? How many networks? Right? What I'm trying to say is, how many different networks? Please try to answer in the chat, please. How many different networks we have in class A? Yes, please answer, everyone. Yeah, please, everyone answer this. Yeah, you can answer to me directly, or you can answer publicly also. Yes, I'm getting correct answers. Okay, see, it's fine if you answer one time. Don't answer it multiple times and all. Okay, now I'll tell you. Yes. Okay, so the number of networks that we have is, yes, 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 enough. Thank you, thank you. Thanks for the answer. Let me continue now. Okay, the number of networks that I have is, okay, this is the network question, correct? This is the network question. Yeah, this is the network question. So what we understood is, if there is a change in the network portion, then we call that as, I'm just gonna stop the chat for a moment, please. Okay, let me continue on the class now. Okay, listen. Okay, now we have only one network portion. All the other three octets are for the host, correct? Yeah. So in that case, since we have only one network portion, totally what is the range of this? 0 to 127. So how many networks we have? We have totally 128 networks. You got the idea? Okay. So let me explain how it is 128 networks, guys. Understand? See, you guys need to follow the classes from the beginning, right? If you are just like to join today's class, then it will be difficult to understand. Okay, so let me explain in my way. So totally, since the first octet is the network portion, there is only one octet, which is the first octet is the network portion, then what is the range of first octet? It varies from 0 to 255. So totally, how many numbers are here? 128 values are there, so which means 120 networks are there. Okay, what if that is 120 network, then what are those 120 networks? Network number one, let's take network number one. What will be network number one, guys? Something that starts with 0. Okay, if you're not understanding now, please watch the recordings a couple of times, guys. You will definitely get it. Okay, so my style of teaching will definitely work for almost all the students. If you're not understanding means, then you may need to watch a couple of times, right? So definitely you'll understand. Okay, so network number one is what? Network number one is 0.x.x.x, right? Anything that starts with 0 will be in one network, right? That is what first network is, right? Anything that starts with 0 will be in the first network. What is network number two? Network number two is anything that starts with 1.x.x.x. Can you understand? Any IP that starts with 0 is in one network. Any IP that starts in 1 is another one network, right? Likewise, if you go, this will be network number 128. So what is network number 128? 127.x.x.x. Can you understand? Yeah. So 0.x.x.x will be the network number 1. 1.x.x.x will be network number 2. And 127.x.x.x will be network number 128. Okay. So now totally how many networks we have? We totally have 120 networks. What are those 120 networks? This guy is network number 1. This guy is network number 2. This guy is network number 128. Hope you understood. Okay, let me take a different slide just to write this in the table. Okay. So now I'm just going to take a table, like I'm just going to write a class. And then next is number of networks. Networks we have in that class. And then number of IPs. Okay, good. So in the class, number of networks, number of IPs. Okay, let us take class A. How many number of networks we have, guys? 128 networks. We have 128 networks. Okay, what those 120 networks are? These guys are that 120 networks. Can you understand? So the subnet mask is 255.0.0.0. In that case, if there is a change in the first octet, then it becomes a different network. So here the change in the first octet means 0 is 1. And then if there is a change in the first octet, which is, if there is a change, this guy becomes a different network. Again, if you keep changing the first octet, you can change it from 0 till 120, right? So totally we have 120, 0 to 127. So totally you have 128 networks. Okay. Now, let's try to understand the next question. That is, how many number of IPs we have in this network? Okay. So now my question is, how many number of IPs we have in each class A network? So we know it's 120 networks, totally 120 networks. But how many number of IPs each network is having? How many number of IPs network 1 or network 2 or any of these 120 networks are having? Okay, now let's take this network number 1 as an example, please. Okay, so network number 1. So what it starts with 0, right? Okay, so now network number 1 starts with 0 and it have to end with 0. That is what network number 1 is. Network number 1 should constantly have this 0. So what is the first thing? It is a 0 network. So it starts with 0. And what is the first IP address of that network number 1? 0 dot 0 dot 0 dot 0. What is the last IP address of network number 1? 0 dot 255 dot 255 dot 255. Okay. Are they in the same network, guys? What is the mask we have? 255 dot 0 dot 0 dot 0. How many network questions we have? Only one network question, right? Do we have any change in the network question of this range of IP addresses? No. All the IP addresses in this range starts with what? Starts with 0, right? Which means this is the 0. This is the network number 1. The range of network number 1 starts with 0.0.0.02, 0.255. The same way if you take network number 2. What is the range of network number 2? 1.0.0.0 from there till 1.255.255.255. Okay. So likewise, you can understand this is one network. Okay. I wrote here like 1 dot x dot x dot x. But here, when you try to expand it and write it, network number 2 starts from 1.0.0.0 till 1.255.255.255. Got the point? Okay. Now, what is the question? What is the second question? The second question is, how many number of IP addresses we have in each class A network? If you take this as one class A network, or if you take this as one class A network, how many number of IPs we have in this range? Yeah. So I'm just going to enable the chat. I want you guys to answer the chat. Okay. So please try to answer. Okay, I'm just going to host it to me only. Right, you can directly answer to me. Yes, please. So what is the answer you would like to say? How many number of IPs we have in this range? How many number of IPs we have in this range? Yes, very good. Many guys are answering it correctly. Yes, okay, good. So now let me tell you. Okay, so now, okay, the answer is right. So most of you guys have given me the correct answer. So the answer is 256 into 256 into 256. That's the answer. Because why? Because here this is 0 to 0. So we are not counting this octet. This is the range, right? 0 to 255. How many octets are there? And how many values are there? Two these values. Into here also how many we have? 256, right? So 256 into 256. Here also how many values we have? 256, right? So 256 into 256 into 256. So if you count from 3 zeros to 3 255s, it is nothing but 256 into 256 into 256. Okay, got it. So this is the number of IPs we have in class A network. So the same is what here also you're gonna have. Like here also, if you count the number of IPs we have in this network, it is also what? 256 into 256 into 25600, right? Which means any class A network, right? Out of this 128 networks you take, any class A network you take, how many number of IPs they're gonna have? They're gonna have 256 power 3. Okay, hope you guys understood. Okay, now let me write it over here. So in class A, totally we have 128 networks. Okay, and then that 128 networks, total number of networks are 128, but the number of IPs in each network, number of IPs per network, I'll write it. Number of IPs per network is 256 power 3. Okay, so 256 into 2 into 256. Okay, so what is it? 256 power 3, 1.67 crore. Okay, it's 1.67 crore. So you know the summary is class A, we totally have 128 networks, and then each network, understand, each network, right? This guy has got 256 power 3. This guy has got 256 power 3. Every network in class A will have 256 power 3 IPs, which is in terms of whole number, it is 1.67 crore. Got it? Yeah, very good. So now we understood class A. Hope you guys are clear. So let me just tell one more time how class A has been calculated. So this is a range of class A, and we start from 0 to 0.0.0.0 to 127.255.255.255. And in class A, the default mask is what? The default mask is 1255 and then 3 zeros. So which means if it is 1255, the first octet is only for the network, right? Yeah. So now how many networks we have totally? 128 networks. What those 120 networks are? Anything that starts with 0 will be in one network. Any IP that starts in 1, they are in another network. Any IP that starts with 2, they'll be in another network. Likewise, totally we have 128 networks over here. Okay, so totally 120 networks. How many number of IPs we have in each network? So starting from 0.0.0.02, 0.255.255.255. Clear? So totally we have 256 into 256 into 256 IPs. Okay. Yes. So now let's try to understand what is class B. Okay, we'll try to understand the class B. We'll try to understand number of networks, number of IPs in that. Okay. Okay. See, and also I just wanted to say one thing, guys. Subnetting, or whatever this classification from today's class, maybe till tomorrow's class, it's going to be full of mathematics. Okay, we're gonna have maths. If you're weak in maths, then you will feel it difficult. If you're good in maths, then you're gonna love the subject. Okay, it's purely mathematics, guys. So subnetting is purely mathematics. That is why most of the guys they get scared about subnetting because they feel mathematics is scary for them, so they don't like subnetting. Okay, anyway, it's not that tough and all. If you try to spend time with subnetting, you can automatically understand it easily. Okay, that is this topic is the most important topic of any networking topics, I can say. Okay, now let's try to understand class B. Okay, what is class B's range? I've given class B's range is this guy. Let me write it over here. So class B. Okay, class B starts with 128.0.0 till 191.255.255.255.255. This is the class B's range. And what is the default mask that we have been given? We have given for class B. Class B has got default mask of 255.255.0.0, which means it says 2 octets of our network, 2 octets for host. Okay, let me write this over here. Okay, and I want you guys to answer my question. Okay, so this is the subnet mask, which is 255.255.0.0. Okay, in that case, this is the network portion, correct? This is the network portion. Okay, so now if this is the network portion, how many number of networks we have? Question number 1, how many number of networks? Can anyone answer? How many number of networks? How many networks in class B? Yes, please try to answer, guys. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, Okay, very few are correct. Okay. Now what? Now I'll answer. Please wait. I'm just going to disable the chat also because it's keep disturbing me actually, the chat messages. So I'm just gonna go and stop the chat. Okay, now. So I'll tell you now. So now 128.0.0.0 till 191.255.255.255. Okay, good. So now in this range, if there is a change in the first two octets, so which defines a different network is, this is a network quotient, right? In this network quotient, if there is a change, then it becomes different network. We all know that, right? If there is a change in network quotient, then it becomes a different network. So now, how simple calculation is, right? What is how many number of values we have here, guys? Starting from 128 till 191, 64 it is. Okay, it's 64. And then how much we have here? 0 to 255. How many values we have here? 256. So basically, the number of networks in class D is 64 into 256. Okay, I think not everyone, but I can say 10 to 15% of answers is correct. It's 64 into 256. Like many guys told 64 alone. It's not 64 alone, guys, because class A only one octet, no, but class B two octets, right? So it's going to be 64 into 256. Okay, it's an easy way to calculate. The number of networks can be easily calculated like this. Maybe if you wanted to know how this is 64 into 256, if you wanted to have this clarity, then I'll try to explain here. Listen. So now let's take, if there is a change in the first two octet, then it becomes a different network, correct? So what will be network number one, guys? What is network number one? 128.0.x.x, correct? 128.0.x.x. Now what is the second network? Second network is 128.1.x.x. Can you understand? It is not 129, guys. It is not 129. After 128.0, what it will be? It will be after 128.0.x.x.x or x.x. The next IP will be 128.1 because there is a change, here there is a change. 128.1.x.x. That becomes the second network, right? What is network number 3? Now it is 128.2.x.x, right? Likewise, it goes till network number 256. Okay. What is network number 256, guys? 128.255.x.x. Still we are in which series only? Now we are in 128 series only. Can you understand? So all these networks that I wrote here, they start with what series? They start with 128 series. Now, what about 129? What will be net? Now, if you take net, if this is 128 series, right? Now, but we have till what? We have till 191. Can you see? Okay. So now, if I take 129 series, if I take 129 series, in 129 series, what will be network number 1? In 129 series, network number 1 will be what? 129.0.x.x. Can you understand? Network number 2, 129 dot, sorry, 129.1.x.x. Likewise, it goes and network number 256, 129.255.x.x. Yes, got it. So now we completed 128 series. Now I completed 129 series. Now I need to repeat it for what? 130. Now 131, 132. I need to keep doing it till what? I need to keep doing it till where class B gets over? 191. Can you understand, guys? With 128 series, I get 256 networks. With 129 as starting octet, I get 256 networks. With 130, I'll again get 256 networks. 131, 256 networks. 132, 256 networks. Okay, so that case, I need to add this now. This 256, this 256 plus this 256 plus this 256. I need to keep adding 256 till where? I need to add 256 till 64 times. Because 128, 256, this 256 plus this 256, which is 129 series, plus this 256, and you need to keep adding it. And finally, it will go, you have to add it till 120, 191 series. Now, that is what I simply say it is 64 into 256. Can you understand? Right? Exactly this 64, sorry, 256 plus 256 plus 256 If you keep adding it for 64 times, that is what it is. That is what 64 into 256 is. Hope you guys are clear. If you are not clear, please watch the recordings, guys. Okay. Maybe if you're not clear, then you are missing something from the previous class. That is what I wanted to say. Maybe you have forgotten or you have not attended the previous session and directly joining this class. That might be the reason. Okay. So I'm very clear with what I'm saying because I've taught this submitting hundreds of times with my students. Right. So all of them they clearly understand it. If you are not getting it, then there is something, something that you have to do from your side. Okay. So now, yes, so we understood the number of how many number of networks we have in class B. 64 into 256. Okay. Yes. So now we'll just write in the summary table. Okay. Class B, how many number of networks is 64 into 256 networks. That many number of networks we have. Okay. So now let's take this guy. Now to find out the number of IPs in each network, we'll take this guy as an example. Now, number of IPs in each network. In one network, how many number of IPs we are trying to have? So let me take this. So if I take 128.0 and extra text, right? Extra text minimum value is what? Okay, 128.0.0.0. That is the minimum value of that 128.0 network. And what is the maximum value of 128.0 network? 120.0.255.255, correct? So now this is the 128.0 network. Can you understand? This is the 128.0 network. And now tell me how many number of IPs we have in this 128.0 network. How many number of IPs? Let me enable the chat and ask you guys. Yeah, please answer. How many number of IPs we have here, please? Okay, please answer. Yes, very good. This is the network portion, but we are talking about the IPs. So IPs means we have to calculate this, right? Okay, this is the host portion. This is network portion. This is the host portion. Okay, so which is 256 into 256. Right, very good. So we have 256 into 256, right? So this is the whole network. This is the total network in which we have 256 into 256 IPs per network. Okay. Yes. So now let's write it like this. So we totally have 64. We totally have 64 into 256 networks, but each network in class B is having 256 into 256 IPs, which is 256 power 2, which is 65,536 IPs. Clear? Good. So now let's go to class. Let's go to class C. Class C. Okay, so class C is what we are generally using in our labs also. No, whatever topic that I teach, I use class C as an example. Okay, let's try to understand that now. 128 dot, sorry, 192. 192.0.0.0. That is the starting range of class C. You can even refer here. Okay, 128.0.0.0 till 223.255.255. Okay, so here 223.255.255.255. Okay, so this is class C's range, right? And what is the mask that we have for class C? You all know, right? 255.255.255.0 guys. Yeah. So now this is a network portion. Okay. Now say how many number of networks. If there is any change in the network portion, then it becomes different network, right? Yeah. So now how many number of networks we have here? How many number of networks we have here? I think people are making mistake in counting this. This is 32 guys. This is 32. 192 to 223 is 32. That value is 32. Okay. So very good. 32 into 256 into 256. Okay, very good. Really nice that you guys are answering and interacting with me. Yes, so the total number of networks that we have in class C is with a given range and given mask 32 into 256 into 256 networks that we have. Okay, these many networks we have in class C. Okay, now next question. Of course, I'm just going to write this over here. This is C, class C. We have 32 into 256 into 256 networks. It's 32 only, guys. If you count it, 192 to 223, it's totally 32 only here. 32 networks. 32 into 256 into 256. Okay. Yes. Okay. So now let's calculate this number of IPs per network. Okay. Let me take simply our example, guys. We're gonna take this network 192.168.1.0. From there, 192.168.1.254. Okay. This is a network question, correct? This is a network question. They are in the same network. Now, how many number of IPs we have here? How many number of IPs? 256 IPs, correct? 2 is IPs, which means single network, any single network in class C will have how many IPs? 256 IPs. Okay, so we're gonna have 256 IPs. Okay, 256. That's it. Okay, so this is the number of IPs per network. This is number of networks in that class, and this is the class, right? So if you take class A, totally 128 networks, but each network is having 1.67 crore IPs. Class B, this is the total number of networks. Each network is having 65,536 IPs. This is class C, total number of networks. Number of IPs per network is 256. Okay. Now I want you guys to guess this. Okay. Now I'm gonna give you some poll questions, which I want you guys to answer. Okay. Assume there is a network. Okay. So there is a network. Like, assume that there is an office network. Okay. And in that office network, we have 100 PCs only. Okay. There is an office which has got 100 PCs. Okay. Now, which class you would choose, right? I'm just going to disable the chat right now. Don't answer in the chat, right? Answer in the poll. So if I have in my office, I have only 100 PCs, 100 PCs only. Which class is recommended? Class A or B or C, right? I want you guys to suggest which class is correct class or the best class to use in a network where we have only 100 PCs. Okay, I'm just going to launch the poll right now. Okay, so this is question 1. Okay. Okay, so now you have the now you're gonna have the poll in front of you. So the question is, so question number 1 is, for question number 1, I mean, now for 100 pieces, okay, for 100 pieces, which class you would choose, right? That's what it is, right? I'm just gonna launch it right now. Okay, so please choose which class you would suggest for 100 pieces, guys. I want everyone to participate in the chat, please. Yeah, I mean in the poll, please participate, please. The poll will be running for 20 more seconds. Please try to answer. Okay, for 100 pieces. Okay, so yes, uh, okay, enough. I'll end the poll. Okay, so we got some 70% participation. That's really nice. Okay, I'll give you the result, guys. Okay, so maybe I can even share the results. Maybe for people who are watching the recordings, we'll give them the result. Class A people, class A 19% took, and class B 8%, and class C 73%. Okay, yes, the right answer is what? The right answer is class C 73%. The majority is correct. Because why, guys? Because in class C, you can have 256 IPs, right? So in class C, if you take this example, 192.168.1.0, okay, till 192.168.1.255. So this is the network, and we all know that this is a network address which cannot be used. The first IP's network address can't be used. The last IP is called as broadcast address, can't be used. So totally you have 256, right? In which usable is how much? 256 minus 2. Usable is 254. Okay. Even if you give one for the router, even if you give one IP for the router, you can still have how many PCs? 253 PCs you can have, no? 253 PCs, correct? Up in that case, my question is what? My question is only 100 PCs. If I have 100 PCs, then which class is sufficient? Class C is sufficient. Okay. See, you can also go with class B, guys. I'm not saying that you should not take class A or you should not take class B. But if you take class A or class B, you're going to have more wastage, correct? Right? The suitable class is what? See, class A or class B is also correct only. But which is suitable class, right? In which class or in which selection you waste less, right? By choosing class C, right? When you take class C, 253 PCs you can have, which is sufficient to accommodate 100 PCs. You got the idea? Yeah. So now that is what 73 percentage they are correct. They felt that choosing class A or class B is also fine, but here you have more wastage, correct? More wastage you got. So the optimal selection is class C only. Okay. Yes. So next question again, the poll is going to come up. I'm going to relaunch the same poll. Let me see. Now the question is, I have 2000 PCs in my network. Now the question is 2000 PCs, guys. I'm just going to launch the poll again. Okay, wait. So there you have the poll now. Now try to answer. For 2000 PCs, which class is correct? 2000 PCs. You want to see this answer? Yeah, see this. The question that has been asked is 2000 PCs. And here you have the table. Please select. For 2000 PCs, which class is correct? See, choose the optimal class, guys. Okay. Yes. Yeah. So now I'll tell you. Yeah, I'll end the poll. So now again, I can see option class A, 8% have opted, class B, 81% have opted, and then class C, 11% have opted. Okay, see, class B is correct. Okay, and then see here, I don't know that 11%, right? I can see a few votes. That 11%, I don't know how they opted class C. Okay, see, class C, now only I told you, right? In class C, how many pieces you can have? You can have only 253 pieces maximum. But what was the question that has been asked? 2000 pieces, right? So if you have 2000 PC network, then how can you use class C, guys? Where you can have only 256 pieces, 253 pieces maximum. Okay. So yes, this class is correct. Okay. So now next question. Again, I'm going to relaunch the poll. This time the question is, I have assumed that I have 2 lakh PCs in my network. I'm just going to relaunch the poll now. Okay, so the question is 2 lakh PCs, guys. Which class you would choose for 2 lakh PCs? 2 lakh. Just see the answer here. This is what the size of the number of IPs in each network. Yes, please, everyone participate, please. Yeah, very good. Please, everyone participate. Recording students, you cannot participate, but anyway, please guess the answer. Okay, let me end the poll now. Okay, so here option A is 92%. Very good. That's correct because you can accommodate 2 lakh PCs in a network, which because here only 65,000 you cannot accommodate. So 2 lakh PCs can be accommodated only in class A. Okay. So A 92%, B 4%, B 4%, and then C also answered 4%. Right. But anyway, this is correct. Yeah. So fine. Let's go and understand this. Okay. Hope you guys understood what is classification, how many IPs they have in one network, and how many number of networks we totally have. And based on what is your size of the organization, either you can go for class A or class B or class C, right? So mostly home networks, right? Home networks, they will be sticking with what? Home networks will be sticking with class C only because how many number of devices you have in your home network is maximum 10 or 15, not more than that, right? But class C can accommodate 254 IP addresses, 254, in which one to the router and 253 to the PC, right? So most of the home networks will have class C only, right? So most of the home networks IP will start with 192.168 because that is class C and because your network is small. Okay. Yes. So class C is for what kind of environment? Home networks, small businesses, they will go for class C. And where generally class B is used. Maybe you can think like universities, colleges, they will go for class B. What about class A? Maybe big multinational companies, MNCs, right? Where they have more than 65,000 devices, they will go for class A. Got the point? Yes. Very good. Now let's try to understand the next thing is. Okay. See, today's class, it is, I know this is little theory only because we don't have any lab as of now. We have to understand the concepts and then only we can do the lab, right? So even for next 30, 40 minutes, it's going to go like this only. Okay. So please stay. Submitting is very important. Please. Anyway, you guys will be getting recordings also, but like attending the live session is more better than watching the recordings. Yes. So now let's go and understand this. So here, let me just go and take the content. Okay, IP classification. I planned to discuss only for 30 minutes, but I know we discussed more than 50 minutes. Okay, so here we'll just try to understand binary to decimal. Okay, and then we'll try to understand subnet classy. Maybe I cannot complete subnet classy because that is alone I planned for 90 minutes. Not possible to complete in today's class. We'll see how it goes. Okay, so now see, this is something that we understood in the school days itself, right? Binary to decimal. So I'm going to write a binary value and I want you guys to guess the decimal value of it. Most of you know it, but anyway, I'll tell you. Most of you, I don't know when you recently learned binary to decimal and all. Right, let me first give you, I'll solve 2-3 sums and then I'll give you the question. I want you guys to answer it in the chat. Okay, yes. So now we'll take this. Right, I'm going to write a binary value that's going to be 8-bit only. I'm just going to give an 8-bit binary value. Okay, let me write one. Randomly, I'm writing something 1. Let me give a space. 1 0 1 0 1 1 0 1. Okay, so this is question number 1, and I want to find out the decimal value of it. How can I find it out? Is it's actually very simple thing. Totally we have 8 bits, right? Okay, so the weightage of this bit is the weightage of the last bit. This guy, right? The least significant bit we call it as LSB. This guy is LSB, but this guy is LSB. The last one, that guy will have a weightage of 2 power 0. Okay, the weightage of that bit is 2 power 0. And then what is the weightage of this guy? This guy is 2 power 1. And this guy, 2 power 2. This guy, 2 power 3. This guy, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Okay, so these are the weightage of those bits. Okay, now what is 2 power 0, guys? We all know 2 power 0 is what? 1, correct? Okay, so 2 power 1 is 2. This guy is going to be 4, 8, 16, 32, 32, 64, 128. So like it starts like 2 power 0 to 2 power 7. Now here I wrote the actual value of the 2 power. Okay. So here, let me just go in. Okay, wait. Let me take laser and then erase this. Okay, cool. So now I wrote the actual value of those bits here. Now wherever you have one, that alone you have to calculate this. So zero you have to ignore. So wherever you have zero, just ignore it. Okay, ignore zero zero. We have these places and all we have zero, but where and all we have one that we have to calculate. Here we have one, no. Yes, this is one, right? So what is the weightage of that bit? One. Okay, we'll add it. We're gonna add. Okay, next here we have zero, so we'll skip it out. We're just not gonna write it. So we'll write this right. This is one again. Wherever the bit is set to one, you have to add that. So this is set to one, right? So what is the actual weightage of that bit? 4. Okay. Again, set. What is the weightage of that bit? 8. Okay. So here is 0, so skip it. Here set. What is the value of that bit? 32. And this is set to 0, leave it. This is set to 1, so add it. So what I wrote is, I wrote wherever I have 1, the weightage of that bit alone I wrote, which means this guy, this guy, this guy, this guy, this guy. Now I need to add them. Okay. So 128 plus 32 plus 128 plus 32 plus 8 plus 4 plus 1. I think this is 173, isn't it? Okay, 160, 173. Yeah, the answer is 170. Okay, so the binary value, this is a binary value, this is a binary value, and the decimal value is 173 because by adding up this, I get it as 173. Good. Now one more example I'll solve. Okay, maybe I'll just go and erase here and I'll write it. I don't have to write it again. I'll just erase this and give you a different question, different example. Here, assume that we have 1, or maybe we'll start with 0, 0, 1, 1, 0, 1, 1, 1. So I want you guys to find out what is the value of this, right? I'll find it out from next question. You guys will, from next, I'll give a question, you guys can answer. Okay. So these guys are set, right? So what it is, we have to add 1, and this is 2, this is 4. Okay, this is 0, so ignore it. This is again set to, sorry, here 4. This is set to 0, ignore it. And then here set to 1, 16. Here set to 1, 32. Okay, here 0, 0, skip it. So now it's going to be what? It's going to be 30 plus 16, 48, 48 plus 4, 52, 52, 55. Okay, 55 is the answer for this. Okay, see, I may make some addition mistakes, guys. I think correct, right? Okay, 55 is the answer. Yeah, so 55 is the answer. Now, likewise, I'll give you some questions right now. I want you guys to answer in the chat. Okay, so randomly, I'm gonna have some questions. Okay, so here you have the weightage. You can just keep add and say it to me. Okay, the question is 1 0 1 0 1 0 1 0. Okay, yes. So let me enable the chat for you guys now. Please wait. Okay, so the chat has been enabled. If you once you find the answer, please message it to me. Okay, good, good. I can get I can see your answers. Okay, it's very good. Okay, so good. So this is 128 plus 32 plus 8 plus 2. The answer is 170. Okay, I can see most of you have answered it correctly. Right, almost all of you guys. There are very few, 1 or 2 answers were wrong. Apart from that, everyone were right. Okay, 170 is the answer. Okay, so new question. 1 1 0 0 1 0 1 1. Yes. What is the answer for this? Okay. Yes. 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 Very good. Very good. The answer is 203. Okay. 128 plus 64, it's 192. 200, 202, 203. Okay. The answer is 203. Okay. Last question, guys. Last question. 1, 0, 0, 1, 1, 1, 1. Yes. What is this? Okay. Very good. The answer is 159. I'm not even actually counting it. Okay, I'm seeing majority of the answers in the chat, and I guess that is correct, and I'm writing it. 159. Yes, 128 plus 16. I think 144. 144 plus 8, 152. 152 plus 7, 159. Correct. Okay. Yes, case. Very good. So one last question before I finish this. That is all one. If all 8 bits are going to be one, then what is the answer? It's going to be the easiest answer. If all one, then what it is? Okay. Okay. See, the answer is actually 255 guys. A few guys are saying 256. That's wrong. It's not 256. It's not 256. It's 255 only. Because why? If you keep adding everything, you will get 255. Which means when you try to write 8 ones, it's going to be nothing but 255 only. The answer is 255. Okay. Okay, it's fine. So now let's get into the actual topic. So here only I'm going to jump into the submitting. Okay, so yes. So before, I think I'm planning to take submitting tomorrow. Uh, I'll just give you the problem statement first. Why do we need submitting in first place? Okay. Now, so there's going to be a question for you guys. Okay. Let me take this topology. Okay. So now I have a question for you guys. The question is, see, this is a topology similar. We know it. I have this interface with 0/0 and this interface with 0/1. Okay. Yeah. Now, my question is, we all know that we configure IP address 1.1 here. Okay. And then we configure 1.2, we configure 1.2. And generally we go to the other side, we configure 2.1, correct? We configure 2.1, we configure 2.2, we configure 2.2. Okay. Now my question is very simple. Can I have 1.1 here and can I have 1.129 here, please? Can I have like this? Can I have 1.1 here and can I have 1.129 here? Is it possible or not? Just answer in the chat. Can I have a network like this? Can I have, just see, simply say, after assigning this IP to this side, can I have this IP address to this side? Yes or no? Simple. Just answer. Yeah. Yes. See, it's actually 50-50. 50% are saying not possible, 50% are saying it's possible. Okay, so let us go to the router and ask him, right? We'll just go and ask him whether he is accepting that or not. EM config. I'll just go to interface FA0/0, IP address 192.168.1.1, 255.255.255.0. Okay, and I'll give no shut to enable the interface. Exit interface FA0/1, IP address 192.168.1.129. This is what I was talking about. First interface, configure it with 0. Sorry, configure it with 1. Okay, listen here. This is what I'm trying to say. This IP has been assigned to this. Now I'm going to assign this IP address. Okay, so can you see 129 for the second interface? Let me just give enter and see what it says. He says it's overlapping. He's not accepting it. And when I give no share, it says what? Incorrect IP address assignment, which means the router is not accepting it. See, most of you, I mean, I can say 50% they told it's not possible. But I don't know why they told it. And 50% told yes, that they were thinking that of course it should be possible because it is also an IP address, right? You can configure this IP to the interface. But why it is not possible? Right? Now the answer is yes, the answer is now when I try to assign 1.129, it says what? If you see the router, what is the error that the router is throwing to me? It is overlapping. It is overlapping. See, now if you take 1.1, what is the network address of 1.1 guys? What is the network address of 1.1? 1.0. Okay, /24. And what is the network address of 1.129? What is the network address? The same 1.0/24, correct? So which means if the IP address that you give on this interface is also having 1.0 network, the IP address that you give on this interface is also having 1.0 network. Now, which means you are connecting 1.0 with another 1.0 with whom? With the router. So what is the duty of the router? Router generally connects what? Router generally connects a different network, correct? Right? We all know we work with routers and all. Routers will connect different network. Okay, they connect different network. But when you try to configure 1.0 on this side, and also if you try to configure 1.0 on this side, the router says that hey, it's overlapping. You already gave 1.0 here. Now you're again saying 1.0 is here. So I'm not gonna accept it. Right? That is why the router says it's overlapping. Okay. Already one interface, you overlap with 0/0. Already 0/0 is also in which network? 1.0. Now you're trying to give this interface also in which network? In 1.0. You got it? So that is why, that is why you always go for a different network, right? So that is the reason after configuring 1.1, 1.2 and 1.3, why am I not configuring 1.4 over here? Why am I not configuring 1.4? Because again, if I configure 1.4, again, this guy will say overlapping. Okay, because 1.0, this guy is also in 1.0 network, this guy is also in 1.0 network. So this way, generally what we do is we configure 2.1. We always go for a different network for the different phase because why? Because router needs different networks on different sites, right? It doesn't like 1.0 on both sides. This is a router which connects different network. So it doesn't like to have same networks on both sides. That is why we configure 2.1 here, 2.2 here, and 2.3 here. Okay. So I agree, I accept. This is how we have been configuring. The reason why I'm not taking 1.4 or any IPs in any IP in one series, I'm not taking it because it will overlap on this side. It will overlap on that network. Okay. So now we have any overlapping? No, we don't have any overlapping because why? This is 1.0 network and this is 2.0 network. Okay. Yes. So now there is no overlapping. So this is fine. Okay. So now let us understand a small problem here, please. Okay. Here, if I take this this is a 1.0 network, correct? 1.0/24 network. Okay. How many number of IPs we have, guys? If you take, it starts from 1.0, ends at 1.255, correct? Okay. Total number of IPs? Total number of IPs or 256? Totally, we have 256 IPs. And how many are actually usable? 1.1 to 1.254. Okay. Yes. So now this is the usable IP addresses in which how many IPs are actually used. So there are totally 254 IPs which can be used. First and last cannot be used because first is network, the last one is broadcast. but the other IPs in between can be used, right? So 254 IPs can be used, in which how many IPs we used here? 1, 2, 3. From 1.1, I used only how many IPs? I used 1.1, 2, 3. What about the other IPs, guys? Do I have those IPs in this network? No. So which means out of this 254 total possible IP addresses, my network uses only 3 IPs. Okay, how many IPs I wasted? 251 IPs has been wasted. Can you understand? So 251 IPs are wasted in this lab. In 1.0 network, I wasted 251 IPs. And now, what in this case? Right? What is the case? How many IPs I wasted here also? The same example. Right here also, 2.0 can't be used. 2.255 can't be used. But 2.1 to 2.254 can be used. But we used only 2.1, 2, and 3. Again, here also, how many IPs wasted? 251 IPs wasted. Can you understand? Now, see, we waste 251 IPs on both sides. Okay, so IP wastages should be minimized. You cannot lavishly spend IP addresses. You have to use the IP addresses properly. Wherever it's possible to reduce the wastage, you should be able to do it. Okay, and also let me take some different labs also right here. Let me take this lab. Okay, here I have got C labs and then ER CCNA Bootcamp lab starting with field office. Let me take this, make a screenshot next time. See here, here how many IPs are wasted, guys? Again, right here, only 1, 2, 3. 3 devices only we have here. So again, how many IPs wasted here? 251 IPs wasted here. Here also how many IPs wasted? 251 wasted. Here also how many IPs wasted? 251. So here all these networks 251 IPs wasted. Here 252 IPs wasted because only how many devices are used? 4.1, 4.1, only 2 IPs used, right? At least here 1, 2, 3. 3 IPs were used. But here in this case, between the router network, how many IPs are used? 252. Here again 252 IPs wasted. Okay. So just see in a small network itself, we are wasting more than 1250 plus IPs. Okay, which is actually not a good design. What is a good design? A good design will have less wastage. That is what the good design is, right? This is how you go when you go to the interview or when you go and go to the networking stream, networking domain. When you go as an architect level, the main important stuff is what? Trying to understand how the network or how the IP address wastage can be reduced. Okay, and now we understood what the problem is. Right now, the problem is IP address wastage, and how do we reduce this? How do we reduce this IP address wastage? With the help of a concept called subnetting. Right, that is why I say this is very very important. Right, and I have seen many students who are in networking, right, but they will struggle with this concept alone, right? I know what is a, if you can, if you know if there are 100 topics in networking, you know 99 topics very well. You are an expert in 99 topics, but that one topic you are weak. And if that one topic happens to be subnetting, then there is no use of knowing these 99 topics. That level of importance is what subnetting is, like, which we're going to discuss in next 2 classes. I want everyone to join the live session. We'll have the next class tomorrow, which is Saturday, and then we'll take a break on Sunday, and then the next class will be on Monday. Okay, so Saturday and Monday, please do join the session and attend submitting classes, which is going to be really, really important. Okay, as I told you, I'm just trying to, tell you how important, stress how important subnetting is going to be. Okay, so yes, so in that case, right, we'll be covering subnetting tomorrow, not today, because if I take today's class will go, it is kind of extending. I don't want to take subnetting today. I want you guys to be fresh tomorrow so that we can understand. So what we understood right now, we understood the problem. What is the problem? IP address wastage is a problem. And how do we solve it? With the help of subnetting. So please try to understand subnetting very well, guys, or else you can never be a very good network engineer in future. Okay. Yes. So let me finish the class here. See you guys tomorrow with subnetting. I'm just going to start submitting directly in tomorrow's class. Okay. Thank you. I'll upload the. See if you have any question, you can ping me in WhatsApp. regarding your question. Video I'll upload today itself. Okay. Thank you, guys. Thank you. Bye. See you tomorrow. Bye.